Winter is beautiful, isn't it? Snow-covered landscapes, cozy nights. But it can be absolutely brutal for your car battery. You get in your car, turn the key, ready to go, and all you get is that dreaded, slow, struggling crank, or even worse, just a click and complete silence. It's a frustrating and common winter problem. So, why does this happen? Why do car batteries seem to give up the ghost the moment the temperature drops? Let's break down the engineering behind it. The heart of the problem lies in the chemistry of your car battery. Standard car batteries are lead-acid batteries. They work by creating a chemical reaction between lead plates and a sulfuric acid electrolyte solution. This reaction produces the electricity needed to power your car, especially the big surge required to start the engine. But here's the catch. Like most chemical reactions, this process is highly dependent on temperature. When the temperature plummets, especially below freezing, this chemical reaction slows down dramatically. Think of it like trying to run through thick mud versus running on a dry track. The cold literally thickens the electrolyte, increasing the battery's internal resistance. This means it becomes much harder for the battery to push out the electrical current your starter motor needs. So, even a battery that's fully charged can fail to deliver that crucial starting jolt on a freezing morning simply because the cold is choking its performance. Let's dive a little deeper into the engineering. Imagine your battery S. Job is to send a powerful army of electrons marching down a chemical pathway to start your engine. In warm weather, that path is clear and wide. But as it gets colder, the pathway gets narrower and more sluggish. The engine starter motor is demanding a huge, immediate burst of current. We are talking hundreds of amps all at once. If the battery's chemical reaction is too slow because of the cold, it just can't supply that power fast enough. It's like a traffic jam for electrons. The battery might have the energy stored, but it can't release it quickly enough. This situation is especially bad for older or weaker batteries. Over time, a battery's total capacity naturally decreases. So, an old battery that was already struggling in the summer is almost guaranteed to fail when winter adds the extra stress of cold temperatures. So, how can you fight back against the cold and prevent these winter battery failures? First and foremost, keep your battery fully charged. A fully charged battery has a lower freezing point and resists the cold much better than a partially discharged one. If you can, using a battery tender or a smart charger overnight is a fantastic idea. Another great tool is a battery warmer or an insulated blanket. These devices help maintain the battery's core temperature, keeping that chemical reaction ready to go before winter even hits. Get your battery tested at an auto parts store or mechanic. If it's weak or more than a few years old, replacing it proactively can save you a huge headache. Also, try to avoid frequent short trips. Your alternator needs time to fully recharge the battery after starting, and short drives of just a few minutes don't give it enough time, slowly draining your battery's life. Finally, a simple but crucial check. Make sure your battery terminals are clean and tight. Corrosion and loose connections create extra resistance, robbing your battery of precious power before it even reaches the starter. By understanding the science behind why batteries struggle in the cold and taking these simple precautions, you can ensure your car starts reliably all season long. It's a perfect example of how a little bit of engineering knowledge can make a real difference in your daily life. Thanks for watching, and drive safe this winter! Don't forget to like and subscribe for more real-world engineering explained.